Scientists believe that the universe was formed over 12 billion years ago as the result of an explosion of an incredibly dense sphere of pure energy. This explanation of the creation of the universe is called the Big Bang theory. The nebula theory is the most popular theory regarding the creation of the solar system. This theory holds that the solar system formed almost 5 billion years ago from a rotating cloud of gas and dust. This cloud contained huge amounts of hydrogen, helium, and other heavier elements. As the cloud rotated faster and faster, it flattened into a disc-like shape and shrank in size. Contraction continued until the density became great enough for fusion to occur at the center of the disk. At various distances from the sun, small currents caused matter in the disk to separate. Gravity caused the matter to collapse into spheres that became larger as they attracted other pieces of matter in their orbits around the sun. Radioactive elements are believed to have heated the matter in these spheres to the melting point. As the spheres cooled, they became the planets that we know today. The remaining matter in the cloud formed other, smaller objects such as moons, asteroids, and meteors. Currently, the solar system contains planets that revolve around the sun in elliptical orbits. There is a large difference in the time it takes each planet to complete its orbit around the sun. Mercury takes only 88 days. The Earth, as we know, takes 365 days, or 1 year, to complete its orbit of the sun. Most of the planets revolve around the sun in orbits that are on about the same plane as Earth's orbit. However, Mercury orbits the sun on slightly different planes. All the planets rotate on their axis in the same west to east direction as the Earth, except Venus and Uranus, which rotate in the opposite direction. It takes Venus 243 days to complete one rotation on its axis, while Jupiter, the largest planet, completes one rotation in just 9 hours and 50 minutes. This causes a swirling and unstable atmosphere on Jupiter. The Earth takes 23 hours and 56 minutes to complete a full rotation on its axis. Early observers, such as the Greeks, proposed that the stars, planets, sun, and moon moved around a stationary Earth. This Earth-centered or geocentric model of the universe continued to be accepted until 1543, when the Polish astronomer Nicholas Copernicus developed a sun-centered or heliocentric model of the universe, in which all planets, including the Earth, revolved around the sun in circular orbits. The German astronomer Kepler modified Copernicus's theory about 50 years later, when he discovered that the planets actually move in elliptical orbits rather than in circular ones. In the late 1600s, the ideas of Sir Isaac Newton helped completely explain Kepler's observations concerning the motion of the planets. There are two major types of planets in the solar system, which are divided by a major asteroid belt that lies between Mars and Jupiter. Asteroids are small, irregular objects, rarely exceeding sizes of more than 120 miles in diameter. Planets inside the asteroid belt, Mercury, Venus, Earth, and Mars, are called the inner planets, while those outside the belt, Jupiter, Saturn, Neptune, Uranus, are called the outer planets. The planets inside the asteroid belt are also often referred to as terrestrial or Earth-like planets, because they are made up of rocky materials like the Earth. On the other hand, the four planets outside the asteroid belt, Jupiter, Saturn, Uranus, and Neptune, are called the Jovian planets. The Jovian planets are largely gaseous and much less dense than the terrestrial planets. Mercury is the closest planet to the Sun at a distance of 58 million kilometers. As expected, the side of Mercury facing the Sun has very high surface temperatures, often reaching up to 400 degrees centigrade. What one might not expect are the extremely cold temperatures found on the side of Mercury facing away from the Sun. Because there is no atmosphere to speak of, heat dissipates rapidly on the dark side of Mercury, where temperatures can reach 200 degrees below zero. Mercury has no atmosphere because its gravitational pull is too weak to prevent gas molecules from escaping into space. Mercury has so little gravity because of its relatively small size. It is the smallest planet in the solar system and has an equatorial diameter roughly 1/3 of the Earth's. The surface of Mercury looks very similar to the Moon. The craters on both the Moon and Mercury were probably formed by massive bombardment from asteroids and meteorites. The surface of Mercury is also covered by crisscrossing ridges that look like wrinkles on its surface. These ridges were probably created as Mercury's surface contracted as the planet cooled. Mercury has a large core of mostly iron that produces a weak magnetic field on the planet. The closest planet to the Earth, Venus, is also almost the same size as Earth. Often, Venus appears in the sky as a very bright, star-like object. The diameter, density, mass, and gravity of Venus are all about equal to Earth's. Venus also has an internal structure very much like Earth's, with a rocky crust, a mantle layer, and a partially liquid core. Unlike Earth, however, Venus has a very weak magnetic field. Another difference between Venus and the Earth are their atmospheres. The surface of Venus is completely marked by dense, pale yellow clouds. Not much was known about the atmosphere or surface of Venus until radio telescopes and unmanned spacecraft penetrated these clouds. The atmosphere of Venus is mostly carbon dioxide, with about 3% nitrogen. Also present are very small percentages of sulfur dioxide, neon, argon, and water vapor. The yellow clouds that shroud Venus consist of droplets of concentrated sulfuric acid, which cover the very dense atmosphere. The atmospheric pressure on Venus is about 90 times greater than on Earth. Radio telescope images of Venus indicate that lightning is constantly flashing within the clouds of Venus. In spite of the thick clouds, the surface of Venus is very hot. The dense atmosphere of carbon dioxide acts like a glass roof on a greenhouse, trapping the radiant heat of the sun. The result is surface temperatures that exceed those even found on Mercury, often reaching 460 degrees centigrade. Radio telescope images of Venus also indicate that there is much volcanic activity on the surface. Venus has no oceans because its high temperatures don't allow water to exist in a liquid state on the planet. Interestingly, the atmosphere of Venus might be much more like that of Earth today if it were not for its extreme temperatures. Like Venus, Earth's atmosphere was once largely composed of carbon dioxide, but most of it dissolved into the oceans that formed in the Earth's Great Basins. Many scientists speculate that Venus was once cooler and had oceans like those on Earth. The next of the inner planets, at 150 million kilometers from the Sun, is the Earth. The Earth is often called the blue planet, as it is covered with oceans, plant life, and an atmosphere of nitrogen, nitrogen oxide, and water vapor that gives it a blue color when observed from space. The circumstances which created life on Earth have yet to be totally understood and explained. As mentioned earlier, the Earth at one point had tremendous amounts of carbon dioxide in its atmosphere, much of which later dissolved in its oceans. Plant life began to use carbon dioxide and solar energy to create energy and food through the process of photosynthesis. One of the byproducts of photosynthesis is oxygen, which is in turn required for animal life to exist. Besides life, another distinguishing feature of the Earth is that it is much more worn down and eroded than any other terrestrial planet, as wind, water, and weathering have broken down the Earth's rocks and created vast valleys of rich soil below the Earth's major mountain ranges. Also, unlike Mercury and Venus, The Earth has an orbiting satellite, the Moon. Between 1969 and 1972, 6 Apollo space missions carried astronauts to the Moon. We learned much from these missions to the Moon. It is now known that many of the Moon's craters were formed over 3 billion years ago, when meteor activity was much greater throughout the solar system than it is today. At the same time, other meteors bombarded the Earth, but many of them were broken up by the Earth's atmosphere, and the craters left by the meteors that actually struck the Earth's surface have been erased by erosion. The Barringer crater in Arizona is the result of a much more recent meteor impact. Evidence brought back from the Apollo missions also indicate that the Moon and the Earth were formed at approximately the same time. One hypothesis proposes that the Moon was created when a large asteroid hit the Earth's surface and propelled part of the Earth's molten mantle and core into orbit around the Earth. Mars is often referred to as the Red Planet. Mars is about 228 million kilometers from the Sun and the first planet to have an orbit outside the Earth's. The redness of the Martian surface is due to soils and rocks that contain compounds of iron and oxygen, much like rust. The diameter of Mars is just more than half that of Earth. The rotation rate of Mars is almost exactly equal to that of Earth, completing the rotation in 24 hours and 37 minutes. Unlike Venus and Earth, Mars has no cloud cover to obscure its surface, and it is easily seen through large telescopes. Daytime temperatures on Mars are often around 25 degrees centigrade, but at night the temperature can drop to around 125 degrees below zero. This is because Mars, like Mercury, has a much less dense atmosphere than Earth. The atmosphere of Mars is about 150 times less dense than Earth and is composed of 95% carbon dioxide, with the rest being mostly nitrogen and argon, with traces of water vapor, oxygen, and other vapors. The surface of Mars has a number of interesting features and distinct older and newer landscapes. The older part of Mars looks like the back of the Earth's moon. It consists of vast plains pitted with craters formed billions of years ago. The newer part has a surface consisting of craterless rolling hills and a series of great canyons called Valles Marineris, which are long enough to reach across the United States. While there is currently no liquid water on Mars, erosion on canyon walls and long meandering channels that look like dry riverbeds indicate that water did once flow on Mars. There is a region of great extinct volcanoes on Mars containing the largest known volcano in the solar system, Olympus Mons, which is 600 kilometers in diameter and 25 kilometers high. In comparison, Earth's highest volcano, Mauna Loa, stands only 8 kilometers above the Pacific floor. Olympus Mons and all the other volcanoes on Mars are no longer active, having become extinct thousands of years ago. Strong winds on the Martian surface cause frequent dust storms that can occasionally cover the entire planet. The polar regions of Mars are covered with ice caps that are believed to be frozen water covered with a thin layer of frozen carbon dioxide. During winter, the ice caps spread about 1/3 of the way to the planet's equator, while during the summer they shrink back to their original size. In 1976, the Vikings 1 and 2 spacecraft went into orbit around Mars, taking over 50,000 photos during 4 years in orbit. The Vikings also sent landers to the Martian surface to perform organic chemistry experiments in search for life on Mars and to record quakes, analyze soil, and record weather patterns. The experiments concluded that the crust of Mars is very stable and there is no seismic activity on the planet. However, the experiments were inconclusive about whether life exists on the Red Planet. Between Mars and Jupiter lies an asteroid belt that contains thousands of small, planet-like bodies called asteroids. Most of the asteroids within the asteroid belt tend to be irregular in shape, which causes them to change in brightness as they rotate. Only the two largest asteroids, Ceres and Pallas, are spherical. Ceres has a diameter of about 1,000 kilometers, while most asteroids are less than 1 kilometer long. Some scientists believe that asteroids were originally planetesimals left over from the solar system's planet-forming period, and that smaller asteroids formed when larger asteroids collided. Jupiter is the largest planet in the solar system and is located 778 million kilometers from the Sun. It has an equatorial diameter roughly 11 times that of the Earth. Despite its enormous size, Jupiter has a relatively low density of only 1.3 grams per cubic centimeter. But even so, Jupiter has twice the total mass of all the other 8 planets combined. Like Venus, Jupiter is shrouded in a thick layer of clouds. The Pioneer 10 and 11 satellites, launched in 1973 and 1974, and the Voyager 1 and 2 space vehicles, launched in 1979 and 1980, have provided scientists with insights into what might lie beneath the mysterious cloud cover of Jupiter. Jupiter rotates faster than any of the other planets, making a full rotation in just under 10 hours. This rapid rotation results in the colored bands of clouds on Jupiter. Jupiter's famous red spot is the result of a hurricane-like swirl of gases in the Jovian atmosphere. Lightning within the swirling red spot is believed to cause a chemical reaction that causes the red color of the gases that comprise it. The wind speed on Jupiter often reaches 360 kilometers per hour. The atmosphere of Jupiter gets more dense with increased depth. A few hundred kilometers below the clouds, scientists believe oceans of liquid hydrogen exist. Jupiter has a small core of rock and ice surrounded by a deep layer of metallic hydrogen. The magnetic field on Jupiter is much stronger than Earth's. This magnetic field is probably the result of large electric currents produced by movements within the metallic hydrogen layer. Hydrogen makes up 90% of Jupiter's atmosphere, and the remaining 10% is almost all helium, with traces of methane, ammonia gas, and water vapor. The alternating light and dark-colored bands of Jupiter run parallel to its equator. Some scientists believe that the light bands are cloudy zones of rising gas, and the dark bands are cloudy belts of descending gases. Sulfur particles and sulfur compounds give the clouds of Jupiter their yellow to orange color. The Voyager 1 satellite observed brilliant auroras and intense lightning storms in the atmosphere of Jupiter. Jupiter is an unusual planet in that it actually radiates more heat back into space than it gets from the Sun. This excess heat is believed to have come from the original heat of Jupiter's formation and from gravitational contraction. Jupiter has at least 16 moons. The 4 largest moons, which were discovered by Galileo, are Europa, Io, Ganymede, and Callisto, and are referred to as Galilean satellites. Ganymede, which is larger than the planet Mercury, is the largest moon in the solar system. It, along with the moon Callisto, greatly resemble the Earth's moon, with many craters and rocky surfaces. Callisto contains a vast expanse of craters, making it the most meteor-impacted moon in the solar system. Io is the moon nearest Jupiter and is perhaps the most interesting moon in the solar system. Its color varies from bright yellow to a reddish-orange. Io is also extremely geologically active. There are at least 10 active volcanoes on this moon, and eruptions as high as 230 kilometers have been observed. The materials that erupt from the volcanoes, sulfur, sulfur dioxide, and other sulfur compounds, give Io its yellow and reddish-orange color. The surface of Io is different from any other body in the solar system. as it shows no signs of the impact craters that are so visible on Mercury, Mars, and many of Jupiter's other moons. Scientists believe that these craters were covered by the lava flows of various volcanoes. The moon Europa is bright white and has many visible cracks. This appearance is believed to result from a highly fractured sheet of ice covering a deep water ocean. In addition to its moons, Jupiter is also circled by a ring of dark rocks, which is only easily visible in infrared photographs of the planet. The ring is about 6,000 kilometers wide, 30 kilometers thick, and circles about 55 kilometers above Jupiter's cloud tops. Saturn is very much like its neighbor Jupiter. It has a rocky core surrounded by water, ice, and liquid hydrogen. Saturn's atmosphere is roughly 94% hydrogen, 6% helium, with very small percentages of methane and ammonia gases. Like Jupiter, Saturn also radiates more heat into space than it receives from the Sun. The winds on Saturn blow even harder than those on Jupiter, but unlike Jupiter, the magnetic field on Saturn is rather weak. Saturn has at least 17 moons, and of these, the largest and most interesting is Titan. Titan is the second largest moon in the solar system, next to Jupiter's Ganymede. It appears to be composed of about equal amounts of rock and water ice. Most of the ice is in the form of a thick shell that reaches nearly halfway to the center of Titan, while the interior half is largely rock. Titan is also the only moon in the solar system known to have a substantial atmosphere. Its atmospheric pressure is about 1.5 times that of Earth, and like Earth, its principal gas is nitrogen, which is assumed to be 90% of the total atmosphere. Most of the remaining gas is methane, with tiny percentages of such hydrocarbons as hydrogen cyanide. Titan's surface temperature is about 80 degrees below 0 centigrade. This is cold enough to condense methane and other hydrocarbon gases, forming a dense fog that hides Titan's surface. The most spectacular feature of Saturn is its rings that revolve around the planet's equator. Viewed from most Earth-based telescopes, Saturn's rings seem to be divided into 3 major systems. However, the Voyager spacecraft, which flew close to the rings of Saturn, found that the rings contained many smaller ringlets, like the grooves of a phonograph record. The rings of Saturn are so much brighter than those of Jupiter because they consist of billions of snowballs of ice and ice-covered rock that reflect the light of the sun. The rings of Saturn are also much wider than those of Jupiter, measuring 10 times their size. Where these rings come from is still a matter of scientific speculation. They could be uncollected materials left over from the creation of the planets. They may be fragments of planetesimals, or they may be remnants of small satellites torn apart by gravity as they approached Saturn. Not much is known about the outer planets of the solar system, Uranus and Neptune. These planets were found much later by astronomers and have yet to undergo the intense study the other planets have. Uranus was discovered in 1781, Neptune in 1846. Both Uranus and Neptune are large gaseous planets, roughly 4 times the diameter of Earth. Both Neptune and Uranus are about 1/3 the equatorial diameter of Jupiter. Uranus and Neptune are thought to have similar interior structures, with dense rocky cores composed mainly of iron, silicon, and their oxygen-containing compounds. Around their respective cores are layers of liquid methane, liquid ammonia, and ice water. These layers are surrounded by atmospheres made up almost entirely of hydrogen and helium, much like Jupiter and Saturn. However, unlike Jupiter and Saturn, a large concentration of methane gas is also present. Because of their lower surface temperatures, both Uranus and Neptune consist more of ice and less of gas than the other large planets, and do not produce any heat, that is dissipated back into space. Uranus has a total of 5 moons. Neptune has 2. Uranus also has 9 very faint rings, none of which is wider than 100 kilometers. The temperatures at the top of the clouds on Neptune and Uranus average around 200 degrees below 0 centigrade. While humankind has been observing the heavens for centuries, it is only in the last 40 years that we have started to explore the universe with spacecraft. In that time, tremendous amounts of data have been collected on our neighbors in space by manned and unmanned space vehicles. The recently repaired Hubble Space Telescope is now sending back to Earth some of the clearest pictures of the universe and our solar system ever taken, and the unmanned Voyager just became the first space vehicle to leave the solar system and enter the vastness beyond. But much more information remains to be gathered before scientists can develop a complete picture of how our solar system and the universe beyond were created and where they are headed.
Okay, visors as required. It is daylight. Putting my visor down. I don't think you'll have direct sun on you.
Well, are you ready for me to go up?
Yes, I am, and I'm heading for the deepest valve as soon as you're out. Okay, yeah, we just saw the sun marching up the side of the telescope there between the whip pick and the FGS.